Okay, hope everybody's having a good day. We are recording now. We'll get back to the double angle identities that we started yesterday in just a moment. Just a few reminders. We turned in the homework today, so if you have any questions on that, let me know. I've had several people come after school because there's no morning tutorials this week. Or if you need to find me in the cafeteria, I'll be walking around, okay, just like the past 2 mornings. But what is happening on Friday? You got your quiz, okay. Well, we had the fire drill last week, so I don't think we'll have one this week.
We had a fire drill?
Mm-hmm. Last, was it Friday? Yeah, yeah.
What period?
8th period.
Oh.
He always likes to do them in 8th period, that way the students can just go and we don't have to get them back in the building. So, hey, that's great. You guys get out 5 minutes early. But the quiz is on Friday, and it's going to cover this material here, the sum and difference identities. Now, originally, when I put together the happy minutes, I believe, nope, didn't have that. Okay, so we're going to continue those happy minutes. I won't have one tomorrow because, I won't be here, but we'll have another one come Thursday. Then we'll have one Friday. We'll have our quiz. Okay, we'll go from there. All right. So let's go ahead and talk about our double angle identities. These were the last set of identities that I introduced to you yesterday. We're going to go ahead and continue to work with them, but they're just formulas. You just plug in the correct fraction. You do a little bit of algebra, and you're going to have the answer that you need. So let's do this. Okay. Let me go ahead and get a white screen here. We had 3 new identities. Well, technically 5 if you think about it. So sine of 2 theta equals, got another text, cosine of 2 theta equals. Then I'm going to leave a little bit of room, tangent of 2 theta. Okay. Now remember, I'm not requiring you to memorize these. If you want to go ahead and do so, completely up to you. And who wouldn't? Because, math is super awesome. But you're going to be able to use your notes on the quiz. You got your test coming up on Monday, March 4th, right before spring break. You'll be able to use your notes on that. Okay, so no issues. Does anybody remember, what does sine of 2 theta equal? Mm-hmm. I heard 2 sine. There we go. 2 sine cosine. So 2 sine of theta times cosine of theta. Perfect. Okay. Now, why did I leave? Yes, ma'am. Oh, one of the notes? There should be some over in the folder over here by Christian. Okay. So why did I leave so much room between cosine of 2 theta and tangent of 2 theta? There you go. Cosine of 2 theta, there are 3 versions that you can go ahead and write. Can anybody tell me one of the 3? Okay. 1 plus? There we go. So 1 minus sine squared of theta.
1 plus cosine squared theta.
No. Switch that around. We're missing the sign and a value. So 2 cosine squared minus 1. And then what's another one, the third? No. It looked almost like your original Pythagorean identity. So cosine squared of theta minus sine squared of theta. Okay. Those were the 3 versions that we had yesterday. All right, let me go ahead and get my notes ready here. Okay. All right. And then tangent of 2 theta, just like the sum or difference, he also goes fractional, but what was his formula? What was up top in the numerator? 2 tangent of theta. Okay. So 2 tangent of theta over 1 minus tangent squared of theta. Yes, that is absolutely right. Okay. Now, there was one other thing I brought up yesterday, and we really haven't seen it, not fully. You can go ahead and plug into the formula for tangent of 2 theta in order to find that answer, but if you're already asked to find sine of 2 theta and cosine of 2 theta, you could just go ahead and conceivably take those answers and divide them. Sine of 2 theta divided by cosine of 2 theta. In fact, I believe that's what we did on our last example yesterday. All right, so these are the last identities we're going to be looking at in here. All right, because once we're done with this section, and I don't imagine we're going to spend a whole lot of time on it, because really there's not a whole lot to it, we'll move on to trig equations, and we'll probably spend a little bit of time on that. Okay, so we talked about these yesterday. What do you learn in college? Well, every university you go to is going to have some basic requirements. You're going to have so many hours of math that you need to take, so many hours of English, and so forth. So in math, it's probably, it depends on your major. Like if your major requires math, okay, yeah, it'll probably start you off, at not the basic levels. But if your degree doesn't require math, you probably could just go ahead and take like the basics, like maybe an Algebra 2 class or even an intro if you want. Something like that. So I think that at Tech, I think it's still 12 hours for math, 12 for English, like 6 fine arts, or at least that's what it was when I graduated. But that, of course, goes back to 2002. So I graduated.
Wow, I was born in 2002.
So, Andrea, you trying to make me feel old here?
Yeah.
So I was in college, just about to start my educational career when you were born.
Yeah.
Crazy.
Even now, I'm crocheting.
There you go. I'm sorry, what, Alza? There you go. I like to think that.
That does
Okay.
not apply to
I
some
think she
people.
means.
Yes, I would agree with that. So, Brandon, what was your question? Uh-huh. Could you take pre-calculus in college? Oh, yeah, absolutely. In fact, they have intermediate classes in college. Um, there are students, unfortunately, who will graduate high school but still have no concept of just, basic algebra. And so they'll made it through high school with no foundation in mathematics. And there are classes geared for people who need that remediation. Basically need to go back and just review the material again. So absolutely. Oh, yeah, they offer all kinds of classes. Okay. Now, of course, my experience comes from Texas Tech because that's where I graduated from, but I'm sure the other universities do the same thing in their curriculum. Okay.
Did you party a lot in college?
I did not. I did not. Because my situation was kind of unique. At the time, my mother was bedridden. She had MS. She wasn't able to clothe herself, feed herself. I mean, everything had to be done for her. And it was at a time when my sister really couldn't deal with what was happening to our mom. So she kind of left to do her own thing, and she had, she eventually came back once she, reconciled everything that she was feeling. But, my parents, they worked hard all their lives, but they weren't able to help me with my college tuition. So I was taking out loans. I was having to pay for college myself. Didn't get a whole lot of scholarships. Just, I don't know.
Because if you did, you wouldn't really have to worry about much.
Yeah, if you got scholarships, I mean, you're good to go. But unfortunately, I didn't qualify for that, for any of them. So I was working pretty much my entire life when I was at college. I was either at school, or I was studying, or I was working, or I was doing something to help my mom. Because the only other person she had was my dad, and he had everything on him, and I just couldn't, leave him to suffer that burden by himself. And I definitely didn't want to leave anyway. So, I mean, kind of hated to bring the room down, but that was kind of my college years right there. So I really didn't have time to party or anything. No. Yeah. So.
What'd you do? Huh? How you struggling?
Okay. So let's see here. Now let's go ahead and pick up where we finished yesterday. We had this triangle right here. Okay. We had this triangle with legs of 1 and 4. We found that the radius was going to be the square root of 17. And what we did was we found sine of 2 theta, cosine 2 theta, and tangent of 2 theta simply by taking those new identities, those formulas, plugging in the correct ratio, and then just simplifying. Okay, so why don't we go ahead and start here again. Now, this wasn't on your notes yesterday, but This does start the notes that you got yesterday after the identities. Okay, so it's a similar type problem, but we do want to go ahead and find or evaluate sine of 2 theta, cosine 2 theta, and then tangent of 2 theta. So let's run through a similar type problem. It says, suppose that sine of theta equals a negative 3/5. Okay, so we have a negative ratio, but we also have that tangent of theta is greater than 0. So greater than 0 means that it's got to be something positive, right? Okay, so answer the following questions about theta. So this one kind of sets it up in steps. A, in which quadrant does theta terminate? Explain your reasoning. Well, you remember, we've seen problems like this before where you have to choose the quadrant based on the sign of your trig functions. What was that sentence that I helped you, that I gave you that helped you remember that? Yeah, all students take calculus. So A, all 6 of them are positive in quadrant 1. Students, sine and cosecant, take, so tangent and cotangent, calculus, cosine and secant. Okay, so let's go ahead and use check marks to help me figure out where these are going to be. So sine is negative, right? Well, if we know that sine is positive in quadrants 1 and 2, it would have to be negative in 3 and 4. So I can not only tell you where they're positive, it can also help you identify where they're negative. So that takes care of the sign of the negative ratio. Now, where is tangent positive again?
3 and 1.
Okay, 3 and 1. So see, I'm using check marks to indicate the quadrants that are possible based on what we have. So why would I say 3? There you go. That's the overlap of the two conditions. So this has to be in quadrant 3. Okay. So it says draw the angle theta and label the reference triangle. So I'm going to go ahead in quadrant 3. There's my terminal side. Now remember, we always connect it to what axis? Always connect it to the x-axis. Okay. So there's the reference angle that we would be referring about. This is theta. Okay. Now, it says sine is negative 3/5. So negative 3/5, what is sine's ratio? It's always y over r. There you go. So I know that the height of this triangle is negative 3 and that the radius would be 5. And again, we're not saying that the height is negative. It's just that the negative tells me the direction that we'd go because we're in this quadrant. Okay. Well, now, before we can go ahead and get down here to C, what's the x value here? What's the base? Okay, let's say Pythagorean. Okay. So let's say that's x. So what are the two legs that I'm going to add after I square them? Okay, so Brandon says x squared plus negative 3 squared should equal 5 squared. All right, so negative 3 squared? Just 9, okay. Is equal to 5 squared. 25. So now I'd subtract the 9. So 16, there we go. So when I take the square root of it, it is 4, but I already heard somebody. Why would it be negative? There you go. Because see, just think about the coordinate plane. If I were going to move from the origin to this point right here, I'd have to go, left and then down. So again, because I go left, it has to be negative. Okay. All right. Did anybody recognize it as a 3, 4, 5 triangle? Pythagorean triple? No, that's okay. There are other versions of it, like a 5, 12. Oh, not 5, 7, 12. 5, 12. Oh, a little high. A little high.
17, 18, 19.
Well, I'm saying a little high, so we need to go low. 13. There we go. 5, 12, 13 is another example of a Pythagorean triple. They're just numbers that... Oh, I'm sorry. That was my fault. Okay.
Yeah.
Well, did I say higher or lower?
Yeah, you said get higher.
No, I said that was a little higher. I said a little higher. Okay, my bad.
Yeah, you can say a little higher. I was like,
My bad. Okay. All right. So is everybody okay with how we determine the quadrant? Okay. Is everybody okay how we set up the triangle? That was step 2. Okay. Now, in order to answer these 3 expressions down here, well, we're going to need sine, cosine, and tangent. So why don't we go ahead and just write those out. Using this triangle, okay. Now, sine of theta, we were already provided that, right? Negative 3/5. So we can see opposite over hypotenuse. So negative 3/5. Okay. So now we need cosine of theta. So what's cosine of theta given that triangle? There you go. It would be x, or the adjacent, over r, the hypotenuse. So negative 4/5. And what is tangent of theta? Okay. So the two negatives would cancel. So we're going to have a 3/4. And remember, in the instructions, didn't it tell us that tangent was positive? And that makes sense. We got a positive number. Okay. So let's start with sine of 2 theta using these ratios here. So sine of 2 theta. Now, you guys told me this at the beginning, but there's no harm in, practicing again. What was the identity for sine of 2 theta? Started with what number? 2. There you go. 2 sine of theta, cosine theta. And all we want to do is just substitute. Okay? For sine of theta, we already know it's negative 3/5, so I'm just going to replace it. Okay? Times, what do we get for cosine of theta? Negative 4/5. Remember, that was coming right off the triangle. Okay? Now, if it helps, take the 2 and put it over 1, because how do we multiply fractions? You just go straight across. Okay? So let's see. I need a 2 times negative 3 times negative 4. So that would be 24 over 1 times 5 times 5. 25. So right there, that is sine of 2 theta. It's just a formula. You plug in the right fraction and you simplify. Okay. Any questions? All right. Okay. Well, now we want cosine of 2 theta. And remember, this one had 3 versions. We had cosine squared of theta minus sine squared of theta. We had 1 minus 2 sine squared of theta. Or we had 2 cosine squared of theta minus 1. Doesn't matter which one I choose. Absolutely not. Okay? Genevieve, which one of those 3 do you like? Which one would you like to use to evaluate cosine 2 theta? The last one? So 2 cosine squared theta minus 1. Okay. So 2 cosine squared of theta minus 1. All right, so I'm going to start with the 2. So again, I just want to plug in the right fraction. What was cosine of theta? Yeah, negative 4/5. We got that from the triangle. So I'm going to plug in the negative 4/5. But what am I forgetting? There you go. Remember, we wanted cosine squared, so I want to make sure to square that fraction. And then we have the minus 1. And now it's just the algebra. Okay. So we take it one step at a time. What would negative 4/5 times negative 4/5 give me? Okay, so 16/25. Okay. So this one's going to be 16/25. We're going to multiply that by 2. So I'm going to go ahead and put him over 1. And then minus 1. Okay. Bless you. So what do I get if I were to double 16/25? 32/25. We just multiply straight across. Minus 1. Okay. Now, what do you think my common denominator will be? 25. There we go. Okay. So basically, what number divided by 25 will give me 1? So I can just change that to 25/25, right? Okay. Now, all we have to do, when you're adding or subtracting, you keep the same denominator. So I'm going to put the 25 here. I'm looking for a 32 minus 25. 7. So that would be cosine of 2 theta. Okay. Now, we didn't have time to do this yesterday. Would anybody like to choose a different formula and show that you're still going to get the same answer? Would anybody like me to show you that? Andrea, you want to see it? No? Yeah, because I thought you were shaking your head yes. So nobody wants to see that? You guys trust me? Marcus, you want to see it? Okay. Which one? Because we already did this one. So which one do you like? Okay, 1 minus 2 sine squared. Let's see if we also get 7/25. So 1 minus 2 sine squared of theta. So I'm just going to substitute in. So 1 minus 2 What was sine of theta? It was negative what? Negative 3/5, right? So instead of the sine, I'm going to put in the negative 3/5, and I don't want to forget to square it. Okay. So let's see if we also end up with 7/25. Okay. Let's see here. What would be a negative 3/5 times negative 3/5? 9/25. Okay. So this would be 1 minus, I'm going to go ahead and put the 2 over 1, because that'll be 9/25. Okay. There you go. Multiply straight across. So 1 minus 18/25. Okay. There you go. Same situation we were in a moment ago. We need the denominator of 25. So that 1, 25 over 25 is 1, right? And what is 25 minus 18? It is 7. So I did get 7/25. So see, it is completely your choice, whichever formula for cosine of 2 theta you like the best. Okay. All right. Good. Okay. Now, we didn't do this yesterday. Let's go ahead and use the formula for tangent of 2 theta. And then we'll just take the ratio of sine 2 theta to cosine 2 theta to see that we get the same answer. Okay. To show you can do whatever you like. So tangent of 2 theta. The only thing is I am forgetting that identity. What goes up top? Okay, so 2 times tangent of theta over 1 minus tangent squared of theta. Okay. So there's the formula for this one. Again, just plug in the right fraction and you simplify. But what is tangent of theta? It is 3/4. Okay. So let's see here. This would be 2 times 3/4 over 1 minus 3/4 squared. Okay. All right, so let's just take it one step at a time. What would I get if I multiplied 2 times 3/4? There you go. So 2 times 3/4 would be 6/4, but 6/4 would reduce to what? 3 over 2. So 3 over 2 divided by. Is everybody okay with that numerator? Okay. So what's a 3/4 times a 3/4? So that'd be 1 minus 9/16. Okay. So I've got the 3/2 up top. So what's the common denominator this time? Okay. So we're working in the denominator now. So 1 is just 16 over 16. Okay. So 3/2 over 16 minus 9. So 7/16. Okay. And what happens when you divide by a fraction? Yeah. And you do what with it? Cross multiply? You can, but you might simplify on the diagonals. Okay. So you multiply by the reciprocal. So this is going to be 3/2 times 16/7. So is there any values here that can simplify before I multiply through? Yeah, there you go. What divides both 2 and 16? 2. So this would be 1. This would be 8. So multiply straight across, it looks like I'm going to get 24/7. All right, good. Now let's test our answer. Let's see if we are correct. Tangent of 2 theta, we got 24/7. So remember, tangent of 2 theta is the same as sine of 2 theta over cosine of 2 theta. Well, what do we get for sine of 2 theta? We got 24/25. Okay. 24/25. Okay. Now we're going to divide that by, what do we get for cosine of 2 theta? 7/25. When we divide by a fraction, we multiply by its reciprocal. So this is 24/25 times 25/7. And you'll notice what cancels. The 25, so I am left with 24/7, which is exactly what we got there. Okay. So really, if you've already found sine of 2 theta and cosine of 2 theta, You don't have to use the formula for tangent of 2 theta unless you really want to. You can just divide out the fractions that you originally had. Okay. Any questions? How are we doing? Any problems? No one? Everybody's seeing where all the values are coming from. Okay. Okay, well, I'll tell you what. We'll go ahead and stop there. I got 31. Thank you guys so much. Again, a great job.